Hi, my name is Dan Lewis. I'm a materials science and engineering professor from Rensselaer Polytechnic Institute, and today I'm going to talk about the mechanical properties of candy. So I have these little sour candies here that we're going to look at. Materials engineers think of the world in terms of structure, processing, and properties. And one of the things materials engineers do is we test materials until they break. And what we do when they break is we look at the fracture surface, and that tells us something about the behavior of the material. So what I've done is I've set up a really simple demonstration where I've got these sour candies at room temperature, and I've got a few of them in the freezer that we're going to test till they fail. So let's set up that demo, and I'll be right back. All right. Okay, so we're back. We have our 3 room temperature candies, and I'm going to ask my helper to break one of those for me. So go ahead and bend one of those. Oop. Okay, it bent all the way and didn't break. All right, cool. All right, so I'm going to go over to the freezer. We're going to get this one. Ready? Give that one a go. Oh, how did that one break? Oh, wow, it broke into 3 pieces. I've not seen that before. Cool. Cool. All right, let's take a close look at one of those surfaces there. Okay. I don't know if you guys can see that. I'll do a close-up of this one a little bit later. But if you look, that one's really shiny. Looks a little bit like
glass.
Yeah, it looks a little bit like a glassy surface. Let's go back to this other one. And if we look at that surface, you can see that one's a little bit more rough, right?
Yeah.
Interestingly, this experiment only worked when the main ingredient of the candy was sugar. Gummy worms and other gelatin-based candies didn't have the same response at low temperature.
The room temperature candy, it changed its shape when we applied a force to it. And when it finally did break apart, we had to pull it. You can see that the fracture surface is very rough. Okay? We call that kind of fracture a ductile fracture. On the other hand, the candy that was in the freezer, when we first started applying force to it, it didn't change its shape at all. In fact, when it broke, it surprised us. And so if you look at that fracture surface, it's very shiny. We might even say it's glassy. Now, at low temperature, the sugar molecules in the candy don't want to move. And so the only thing the material can do is fracture like this. We call that a brittle failure. So we have one material, 2 temperatures, 2 different atomic mechanisms, one ductile, one brittle. Material scientists can use information from fracture surfaces to help design better materials. Because if we know how they're going to fail, then we can engineer those materials and engineer those structures to better respond to mechanical stresses. So thanks for listening. Reach out to me if you want to know more about engineering or more about materials engineering. And if this kind of thinking is something that really excites you, you might want to think of a career in materials science and engineering. So take care. Thanks for watching. Be well, and we'll see you next time.
Another one.
What are you doing? Don't eat the experiments.